Good day, my dear statistics students. We are now going to discuss about determining probabilities. At the end of the lesson, you are expected to identify regions under the normal curve. Find the shaded region under the normal curve given specific conditions. What is standard normal distribution? It is a normal distribution with mean mu is equal to 0 and standard deviation is equal to 1. Standard normal random variable, that is the random variable with a standard normal distribution, denoted by x. Mathematicians are not fond of lengthy expressions. They do denotations, notations, or symbols instead. Learning the probability notations under the normal curve. The following notations for a random variable are used in our various solutions concerning the normal curve. P, A is less than Z is less than B. The probability that Z score is between A and B. P, Z is greater than A. This denotes the probability that the Z score is greater than A. P, Z is less than A. This denotes that the probability that the Z score is less than A. To denote the area between Z is equal to 1 and Z is equal to 2, we use the notation P, parenthesis 1 is less than Z is less than 2, which is equal to 0.1359. The probability that the Z score falls between Z is equal to 1 and Z is equal to 2 is 0.1359. With continuous probability distribution, such as the normal distribution, P, Z is equal to A is equal to 0. This means that with infinitely many different possible values, the probability of getting one exact value is 0. For example, take Z is equal to 1.22 exactly. A single point like 1.22 would be represented graphically by vertical line above 1.22, but the vertical line contains no area. So, P, Z is equal to 1.22 is equal to 0. With any continuous random variable, the probability of any one exact value is 0. So, P of A is less than or equal to Z is less than equal to B is equal to P of A is less than Z is less than B. It follows that the probability of getting a score at most B is equal to the probability of getting a score less than B. Modified steps in determining areas under the normal curve. First, use a cardboard model to draw a normal curve. Number 2, locate the given Z value or values at the baseline. 3. Draw a vertical line through these values. Number 4. Shade the required region. Find models if any. Number 5. Consult the Z table to find the areas that correspond to the given Z value or values. Number 6. Examine the graph and use probability notation to form an equation showing an appropriate operation to get the required area. Number 7. Make a statement indicating the required area. Let's familiarize some of the terms involved using notations. Negative. P, Z is less than A. So this is less than Z, to the left of Z, below Z, lower than Z, under Z. For the positive, P, Z is greater than A. So this is greater than Z, to the right of Z, above Z, more than Z, at least Z. Find the proportion of the areas. Area above Z is equal to -1. Area greater than Z is equal to 1. Area to the left of Z is equal to -1.5. Area below Z is equal to 1.5. Between Z is equal to -2 and Z is equal to -1.5. Between Z is equal to -1.32 and Z is equal to 2.37. Case number 1. The required area is greater than Z, at least Z, more than Z, to the right of Z, above Z. Area above Z is equal to -1. So the graph looks like this. So take note of the word above. So it means to the right of Z. So we shall find first the area on 0 and to the -1. So that is 0.3413. And what is left is on the right side. That is, the area of that one is 0.5. So PZ is greater than -1 is equal to 0.3413 plus 0.5, which is equal to 0.8413. The proportion of the area above Z is equal to -1 is 0.8413. Area greater than Z is equal to 1. So this is now the graph. So P of Z is greater than 1, that is equal to 0.5 minus 0.3413. We shall subtract this one because we're going to find the area of the other one. So that would be 0.1587. The proportion of the area greater than Z is equal to 1 is 0.1587. Case 2. The required area is less than Z to the left of Z. Area to the left of Z is equal to -1.5. So this is the graph. So P of Z is less than -1.5, that is equal to 0.5 minus 0.4332. That would be 0.0668. The proportion of the area to the left of Z is equal to -1.5 is 0.0668. Area below Z is equal to 1.5. So here is the graph. So P Z is less than 1.5 is equal to 1.5 plus 0.4332. So that is 0.9332. So the proportion of the area to the left of Z is equal to 1.5 is 0.9332. Case number 3. Models when the required area is between Z1 and Z2. Find the area between Z is equal to -2 and Z is equal to -1.5. So here is the graph. Z is equal to 2 corresponds to 0.4772. Z is equal to -1.5 corresponds to 0.4332. So P negative 2 is less than z is less than negative 1.5, that is equal to 0.4772 minus 0.4332, which is equal to 0.0440. So the required area between z is equal to negative 2 and z is equal to 1.5 is 0.0440. Case number 4. The area is between negative z and positive z. Find the area between z is equal to negative 1.32 and z is equal to 2.37. Z is equal to negative 1.32 corresponds to 0.4066. Z is equal to 2.37 corresponds to 0.4911. So here is the graph. So P negative 1.32 is less than Z is less than 2.37 is equal to 0.4066 plus 0.4932, which is equal to 0.8998. The required area between Z is equal to negative 1.32 and Z is equal to 2.37 is 0.8998. Now here are the references. Thank you very much for watching and listening. Subscribe to Analyze Math.